If a white hole fought a black hole.
The committee holds him responsible.
That's how it starts.
Believe it or not, but more things have happened in the past 25 years. A lot of things have happened, and a lot of them were, of course, done by people younger than me.
And here's what would happen.
And they were helped greatly by having the ADS-TFT correspondence as a concrete setting where you can study a specific theory that actually is the quantum gravity theory and check that the ideas you have about how information and space-time work against what you know about that theory. So you can have a lot more confidence that your ideas are right, even if those ideas are perhaps more complex and more refined and a little bit otherwise would be harder to check. So one of the key things that we have learned, which I think we now understand fits into this actually very general scheme that applies to all spacetimes, not just ADS, but which was first understood by studying ADS, is this idea that the way that a gravitating spacetime encodes our local information into a quantum state is an example of something called a quantum error correcting code. Something that people began studying also many years ago, the significance of which I did not appreciate at the time. I thought it was maybe a bit of an engineering problem. When you build a quantum computer, those things are not perfect. They lose information sometimes, and you want to build in a kind of redundancy that protects against the loss of information to an environment that degrades your quantum information inside the quantum computer. You can't do that in the same way as you do it with classical information by just duplicating it, because quantum information cannot be cloned. But there are other ways of doing it that are more subtle and sophisticated. That
responded as of yet.
I'm just speculating. But I think whoever's at the helm of that thing is looking to make a dramatic
entrance. I think Almeri, who I also mentioned before, subtle and sophisticated clone. But there are other ways of doing it that are more subtle and sophisticated. Means that I can quantum error correct. That the quantum information is encoded in ADS. Shidong and others understood that in ADS-CFT the way that the quantum information is encoded,
there, having grown into an adult.
That is precisely a quantum error correcting code. That means that I can give you different parts of the boundary of the space-time. If I give you 2/3 of the boundary, it doesn't matter which 2/3 I give you, you can reconstruct what's in the center of the space-time. But if I give you only 1/3, you have absolutely no idea. This is the kind of thing that happens in quantum error correcting codes. Over time, that relation was further refined. My colleague here, Jeff Pennington, and my former student Chris Akers pointed out that the way the information is encoded on the boundary, so in order for the information to end up on the
harsher environment than Earth.
You have to sort of, it's as if gravity was solving a particular quantum communication.
Long ago,
where I'm trying to send you a message.
An era of expansion.
I have certain resources available.
Our race spread out through the stars.
The areas of space-time.
Seeking new worlds
I can successfully send you the message if the message isn't too long.
The scout ship is one of thousands launched into the void.
I basically burn up these resources by sending you the message, so
you get outposts, using great machines to reshape environments to our needs.
Because we're lazy are so-called asymptotic problems, where
for 100,000 years,
by imagining that
our civilization
like many of you and me, and each one is trying to send that message to the other. But we get to take advantage of certain ways of sort of compactifying.
Artificial population control.
Just like creating a zip file or something on your computer.
The outposts and space exploration are
redundancies and save resources by doing
exhausted our natural resources.
And
as a result,
the resources that you then need is
our planet's core became unstable. Eventually, our military leader,
well, in the real world,
General
it's
Zhao,
rarely the case that there's many
attempted a coup.
copies of you and me, and so we must solve what we call a single-shot quantum communication problem.
Your mother and I
don't
foresaw the
get to
coming
take advantage of extra redundancy,
took certain steps to ensure your survival.
And so on. And in that case, the amount of
This is a
resources that I
Genesis
need to send you
chamber.
the same message
All
is in general
kryptonians
higher.
were conceived in
And
chambers such as this.
measured by something
Every
called
child was
the
designed to fulfill a predetermined role in our
In fact,
society.
to my
As a
knowledge,
worker,
only
warrior,
reduced into
leader,
quantum
soul.
information theory.
Your mother and I
others
believe
in
Krypton
the
lost something
laws
precious. The element of choice,
this
of
millennium.
chance.
And what
What if a child dreamed of
my
becoming
student
something other than
Chris
what
Akers
society
and
intended
my
for him
colleague
to
Jeff
be?
Pennington realized is that actually
What if a child
governs
aspired to something
what
greater?
region you can reconstruct from the boundary.
You were the embodiment of that
So
belief, Cal.
it's the
Krypton's
areas
first natural birth
have to
centuries.
have to be viewed as a resource, not
That's why we
for
risked so much to save you.
weighed against the von Neumann entropy
Why didn't you come with
of
me?
the quantum information in the matter that's in the universe,
You couldn't
but this
count.
weird new thing called the, to me new,
No matter how much
called
we wanted
the smooth max conditional
matter how much
entropy.
we loved
Those
you.
are the things that enter. Okay, so this was
Your
to
mother
me
and I
another
were a
revelation.
product of the failures of our world as much as
Increasingly sophisticated concepts from quantum information theory enter into how space
You're as
and
much a
time
child of
actually
Earth
emerge.
now as you are of
And
Krypton.
it's, I'm going to be honest here, that I would have dismissed as overly related to practical
Dream your
engineering
mother and I dedicated
problems.
our lives to preserve.
You know, I know I was like, why is John Preskill working on quantum error correction? Like, who cares about errors? You know, those are practical issues.
I know, it's crazy, right?
What a loss to our
The
field,
Americans
you
are there
know,
too.
and now he's not working on black holes anymore. I'm so sad. Well, he was way ahead of the rest of us. And then single shot versus asymptotic quantum communication problems. You know, one is this sort of idealized thing that you might think will enter into a quantum theory. The other might strike you as, you know, a practical problem unlikely to show up in a fundamental theory of physics. Well, gravity thinks like an engineer. It's
What if? Before we get to our fight, let's see what these two opponents are all about.
it's a wonderful, I think it's a wonderful story that we've been taught again and again, that these sort of very applied real life almost concepts from quantum information theory are the ones that matter the most in our growing understanding of how space and time emerge. And so that's been, that's been a wonderful thing to be part of. Another, by the way, just to squeeze that in, is that gravity is so powerful, and its sort of hidden knowledge about quantum mechanics is so powerful that we've discovered new things about theories that have nothing to do with gravity naively, about quantum field theory, like the standard model of particle physics. We have for the first time a lower bound on the energy density of matter. Energy density of matter can be negative. So zero is not a lower bound on it. Like, you can have some negative amount of energy in a small region of space. That's totally okay as long as there's positive energy elsewhere. But we never had an actual expression for how low it can go. We discovered such an expression by thinking about how gravity organizes quantum information. It's very easy to derive from a fairly simple conjecture about how that should work. And we got this very nice expression that has no gravitational constants in it. So it looks like it's purely a quantum field theory statement. And then people went and wrote down 100-page proofs in quantum field theory.
Get up,
Using all of the powerful methods of algebraic quantum field theory that I didn't even know about, to show that this is really true. But I think it's extremely remarkable that gravity knows so much about quantum mechanics that we can effectively use it as a discovery tool about a theory which naively we have far better control over, we completely understand, and so on. We still discover something new about it. I guess what I won't get into is the question of whether something is real. I think that's never been a fruitful question in science. The question is, what is an efficient description of our data? But what we can ask is, to what extent do we think some property is emergent as opposed to fundamental? So, for example, the conductivity of a metal.
You're all right. You just have to decide what kind of man you want to grow up to be, Clark, because
So bad.
whoever that man is, good character or bad, he's going to change the world.